The economic order quantity has been a proven model across many venues and is a commonly used technique to control inventory. The objective is to minimize the total cost of the inventory. Here are the assumptions of the economic order quantity. And as you can see, the first two are deterministic in nature, meaning that we know what it is. So we know what the demand is, and we know what the lead time is. And of course, we have the receipt of the inventory is instantaneous, and we know what the cost is, so there's another deterministic factor. On the other hand, we have variable cost. And those variable costs include cost of ordering and carrying and holding. And the key is that we want to avoid stockouts and shortages. Well, what happens to inventory over time? Well, we have an inventory level, and we call that level that we started is the maximum inventory level. And we give that value a letter Q. And of course, what happens realistically in the sense of understanding what's going on, we have an inventory. And with this inventory, our inventory is going to be depleted. And how far can our inventory be depleted? Well, our inventory can actually be depleted down to zero. Well, what happens when we get our inventory at zero? Well, ideally, we want that inventory to get to zero and then automatically replenish our stock. And then we let it go back down to zero, then automatically or instantaneously replenish our stock. And that's what this diagram shows. Now we will look at the inventory cost when we use the average inventory level, and then we will be able to compute the average inventory. So as you recall in our last section, we know that Q is the maximum inventory level. So the average inventory level, we will consider taking Q and dividing it by 2. So if we look at the chart below, you will see that we started April the 1st with our beginning inventory level, and we have our ending inventory, and we have our average by taking 10 plus 8 and divided by 2, we get 9, so forth and so on. So if we look at the maximum level on April the 1st, we have 10 units, and we have an average, a total of daily averages is 25. So we're taking the column to the right and taking the average of that column, and we find that the average inventory level is 25 divided by 5, which is 5 units. So when we look at the inventory cost in the economic order quantity situation, we have a number of pieces to the puzzle. And here we present the pieces to the puzzle and what we call each piece to the puzzle. We have Q, which is the number of pieces to order. We have Q star, which is the optimum number of pieces to order. We have our demand, we have our ordering cost, and we have our holding cost. So if we look at the annual ordering cost, the annual ordering cost is the number of orders placed per year times what they cost. And that makes sense because I know if I have so many items that I need to order and I know what the cost is, simply to know how much it's going to cost me, I just multiply the number times that cost. So, well, what is this annual demand? Well, the annual demand is what we're looking for annually, and then that's divided by the total number of units. So in order to get our annual ordering costs, we have our demand divided by the quantity times our cost for ordering each unit. So we have four pieces to this puzzle. We have the annual ordering cost, we have the demand, we have the number of pieces that we want to order, and we have the ordering cost for each piece. So in this deterministic model, we're going to be given these pieces to the puzzle, and once we're given these pieces to the puzzle, then we are able to find out what the annual ordering cost is. Okay, so here again we have the same situation, and we want to know what the annual holding cost is. So what is the holding cost? Well, that's the cost to hold the inventory, to keep the inventory on hand. So we take that average that we're looking for, and we note that we identified the average inventory in the previous slide as Q divided by 2, and then we multiply that times what it costs for us to carry the units. And so when we do that, we get Q, again, which is the number of pieces to order, divided by 2, which is our average inventory, times the cost that we have to spend to hold the items. So we have annual holding costs that we compute. Now, here's what it looks like from a graphical perspective. And remember that we're trying to minimize total cost. And the point where we minimize total cost is where the cost of carrying the items is equal to the cost of ordering the items. And this is what the graph depicts here. When these two curves are equal, we call this the optimum order quality. And at the optimum order quantity, we're going to have the minimum cost. So, bringing our graph with us and taking the annual ordering cost, which we computed earlier, and the annual holding cost, and setting them equal to one another. And in this case, what is it that we want to do? Well, we want to solve for Q. And in solving for Q, we take it through a series of basic algebraic manipulations. And when we take it through our basic algebraic manipulations, we find out that when we isolate Q to one side, we find that Q is equal to the square root of 2 times my demand times my ordering cost divided by the cost of holding. And when we compute this, this Q now becomes our minimum cost, or minimum quantity, or our optimum Q star. So here's a summary of the equations. And using these two equations, we come up with the economic order quantity. Now, well, here's an example. Give me the information, and I will put the information into my puzzle box, as we call it, and I will find the information that I'm looking for. So in the practical application that we have here, we have Sumco Pump Company, and we're given the annual demand, we're given the ordering cost, and we're giving the average cost for carrying a unit per year, which is 50 cents. And so when we put that in our model, we find out that the optimum order quantity, or the EOQ, is 200 units. Well, we have something else that we can compute, and the total is called the total annual cost. And what is that total annual cost? Well, it's nothing more than the cost of ordering the units plus the cost of holding the units. And again, I have this information. I know what the demand is. I know what the cost for ordering it is. I know what my optimum quantity is. And I know what my holding cost is. So I have all the pieces to this puzzle. And again, through basic algebra or basic mathematical computations, I can find out that my total annual cost is $100. Now, we can also do this in QM for Excel. So if we look at our QM, and as you can see here, once you have embedded QM into your Excel, you can go to the QM tab, and once you get to the QM tab, you're going to click on alphabetical. Now, the topic that we're discussing is inventory, and we're discussing the topic of economic order quantity. And then once I click on economic order quantity, I'm going to type in the name of my company, or the title, and in this case is the Sumco Pump Company. And to keep my spreadsheet in order, I'm just going to give this sheet a name so I know what it is, and I'm just going to call it SPC, and I'm going to click the box on reorder point, and then I'm going to hit OK. My holding cost is fixed, so I'm going to hit OK, and then I'm going to get this information shown here, and it is asking me to enter the demand rate, the setup cost, the holding cost, the unit price, and then once I do that, it's automatically going to give me the numbers that we just computed. So if I did that and I inputted the data, and this is an older version of QM for Windows, but we get the same information. So we know that the demand rate is 1,000, it costs us $10, and the holding cost is 50 cents. And once we put that information in, these are the formulas that it's going to use to calculate that information. And then once we hit the OK, put the information in, it's going to automatically populate the information. Okay, and what we end up with is the holding cost, the setup cost, and as you know, we do not have the unit price, so we leave that blank, and we're going to get what we came up with before. The total cost is $100. The optimum order quality, or the EOQ, is 200. And if I did this in my 2007 Excel, I'm going to put in 1010 and 0.5. I will leave these blank, and I get the same information.